All right, it's me. So we're ready to learn the last new thing. Hopefully, did everybody read this beginning? So this is our last new skill. There's some words that I want to make sure everybody knows. Okay, so hopefully you did the opener. Okay, and so the idea is if you're looking at a ratio of functions, and we're going to assume that we're going to put the x to a some number, okay, that there's a couple special cases where we can use calculus to help us figure out the limits. But here's what has to happen. This has to be worth 0 when you plug in c to the function. And this has to be worth 0 when you plug in c to the function. And if both those things are true, we say that 0 over 0, it turns out what you can do is take the derivative of the numerator and take the derivative of the denominator and try again. And it's named after this French guy. That's him. His name's L'Hopital. Okay. And the way that mathematicians read this is they say, oh, that's the form 0 over 0. And that's one of what are called indeterminate forms. Okay. And the word root in there is to determine, because there's some forms you can determine just by thinking about them. And that's what we did at the beginning of our time together. That's what you do in pre-calculus. Like if you have something where the numerator is going to 1 or 7 or 8, I think in class I used the number k, and the bottom is getting ginormously big, that's going to approach 0. You don't have to do anything more. You know, a fixed number over something that's getting increasingly large goes to 0. And then we did the ones too, like what if you've got a fixed number and you're going to something that's 0? But you have to be a little more careful with 1 over 0. You have to check about the sign. So you have to look at the numerator sign and the denominator sign. So if you just do 1 over something that's really, really tiny but positive, that's going to explode up. And that approaches plus infinity. And those are the ones we talked about at the beginning of the year. Okay? But we're going to look at this new one. And we did it with our calculator. I'm not sure how the AP test is going to look this year for you guys, but they would not give you this with the calculator. So how do we know that this is something interesting? How do we know that we should evaluate the limit? Well, the first thing you always want to check is maybe you can just input the number and it's just like a normal 2 algebra 1. So let's do that on the side. If I do the sine of, if you put pi in, that would be 2 pi. But in the denominator, you get pi minus pi. And really, that means that this is worth 0, and this you're dividing by 0. So since we're dividing by 0, we know there's now output there. But since we have a ratio of 0 over 0, we can use L'Hopital's rule. Okay, let's see. So what does L'Hopital's rule say? We're going to do a new limit. We're going to approach the same number, but now we're going to use our derivative skills. So we're going to take the derivative of the numerator, and the derivative of a sine is cosine. Keep the same input, and then take the derivative of the denominator. Pi is a constant, so its derivative is 0. The derivative of negative x is negative 1. And then what happens is we just try again. So you go and you see if you can input the pi in, and hopefully you change to a format that now we can evaluate. Okay, so let's try on the side. So if you put a pi in, you would, that's my dog, you would get cosine of 2 pi. And in the denominator, you get negative 1. But 2 pi ends up here, so it's 1 over negative 1, which is negative 1, which we found from our calculator. And so the thing is, you can use this rule for these forms if you have 0 over 0 or infinity over infinity. And sometimes you have to do it a couple times. Okay? And you can't use it for this version, this one, because if I tried to evaluate at pi, you would have cosine of 2 pi over pi minus pi, which is cosine of 2 pi is 1 over 0. And that's not one of the forms. So we can't we can't use, get a pen, got a little lag. We can't use that L'Hopital's rule.